All right. Any group having ideas what these numbers might have in common? Yeah, Alana, go ahead. Shh. Oh, up top, all these numbers are squares, and all these numbers down here are cubes. That is exactly what we were looking for there. Now, if you haven't seen these before, if you have not heard of these numbers before, squared numbers, cube numbers, that's exactly what we're working with today. Okay, so again, I didn't expect you just to know these unless you've actually done something with them. But basically, when we say squares, that means we took some number and we squared it. Cubes, that means we took some number and cubed it. So let's take like 9, for example. 9 we obtained by doing 3 squared, which is 3 times 3, and how we get 9. Okay, 16 is 4 squared, or 4 times 4. 36, 6 squared, 6 times 6. The cubing, now we're just taking some number and multiplying it by itself 3 times. So 8 is the result of 2 cubed, or 2 times 2 times 2. 2 times 2 is 4, times 2 again gets us to 8. So we're going to be working with these numbers today. I do not expect you to memorize squares and cubes. The more familiar you are with them, the easier some of this stuff gets, and you will be working with square numbers and cube numbers, heck, this year, next year, every year that you're working with math. So just to help visualize some of these things, a perfect square, the reason why, or part of why it's called a perfect square, is if we have any sort of object that has these dimensions, we can get a perfect square because the length and width are the exact same. So this first example is a 1 by 1. 1 times 1 equals 1. Also 1 squared there. Next one is 2 by 2. If I do 2 times 2, that's 4. Makes a perfect square. 2 squared is 4. Okay, so there's a visual that applies to all of these. Okay, and also kind of where that term comes from. Now, how that visual gets applied to a perfect cube is we add a third dimension to it. So instead of it having a length and a width, or width and a length, now we also have depth to it. Okay, so length, width, and depth. And that makes a perfect cube, so 3 dimensions. Okay, but still the perfect part means that we obtain all these squares everywhere. All right, so I said I don't expect you to memorize perfect squares or perfect cubes. If you ever need to work with them, this list is really helpful and really easy to make. If I don't know that 9 is a perfect square or 16 is a perfect square, I can figure out what those perfect squares are by just taking any whole number and squaring it or multiplying it by itself. So these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, all these are the perfect squares, up to 12 squared. This list, as you're working through the lesson for today, we should constantly be flipping back and looking at this list. Everything we do today is revolved around this list of perfect squares and then perfect cubes. And that's something that we need to get better at. I have started to grade our quizzes. It's clear that some of us are not looking at these notes and thinking about what we're writing down. Okay, so these notes, we're not just doing this to waste time in here. We're building notes, that way you have resources to work through assignments and to get ready for assessments. All right, then as soon as we multiply it by itself that third time, we get this perfect cube list. So 1, 8, 27, 64, 125, 216. As you can see, they get big really quick because of that third multiplying. It's a perfect cube. And again, we should constantly be referring back to this page as we work through this lesson today. Got a writing utensil. Okay. Now, what we're doing with these numbers today is instead of squaring a number or cubing a number, we're going to go in the reverse process of that. And we're going to undo a square or undo a cube by taking what's called a root. That's what we're seeing over here. Okay, so we know that 3 squared is 9. If we see this symbol is called the square root of 9. And what we're trying to think about is what number times itself gets us to 9. And there's actually 2 answers there, right? Because I can get 3 times 3 is 9, but also negative 3 times negative 3 is 9. Now, we'll just focus on the positives for this today. But when we see this number or this symbol, the square root, we're thinking what times itself is 9. Okay, so that's where the list is really helpful. If I see 9, I can go, oh, I know that's part of my perfect square. So there's 9, and thus the square root of 9 is me undoing the squaring, and thus it is 3. Okay, so as we figure out what numbers we're either taking the square root or cube root of, we'll figure out what the actual number squared is to get us to that value. Now the cube part's a little bit different and a little bit harder because of that third multiplication that happens here. The addition of that third multiplication allows us to deal with negative values. So negative 3 cubed, if I have negative 3 times negative 3 times negative 3, that is a negative number, right? This negative times the negative is a positive 9. 9 times this last negative 3 gets me to negative 27. So if we are cube rooting negative 27, it is equal to a negative 3. And now what we are asking ourselves is what number times itself what times itself 3 times is negative 27. So again, exponents and roots are inverse operations in the same way that addition and subtraction are inverse operations. So squaring something and square rooting something undo one another. Cubing and cube rooting something undo one another as well. All right, so go ahead and flip this page over. Let's skip right here. This is important. How many possible roots are there for each perfect square, and why is this? So let's use an example here. If I take the square root of 4, what's the answer to that? Remember, opposite way. We're not squaring it. We're thinking what times itself is 4. Nico, what did we say? 2. Is there another number times itself that gives me a positive 4? What did you say, Cece? Negative 2. Okay, so because a negative times a negative is a positive, when we take square roots, it can be positive and or negative. Usually it's going to specify. So if we see just like root 4, this is asking for the positive root. If we see plus or minus root 4, that's when we'd say the plus or minus 2. Okay, but because of it being times itself, when we take the root, it can be negative. What about this, though? What number times itself is negative 4? Does this one exist? No. Right? A lot of students will say, oh, yeah, that's negative 2. But negative 2 times the negative 2 gets us back to the positive 4. Okay, so if we're square rooting a negative, this is a non-real number. Eventually, you'll learn about an imaginary number that allows us to work with those negative roots. But for now, if we are square rooting a negative, that is not possible. Now, again, that's different when we cube root. If I cube root, let's say 8, that is only 2, and that's cube root. It is only 2. It is not plus or minus. Okay, because of the third multiplying the number by itself 3 times, we're only able to use one sign here. So cube root of 8 is just 2. Cube root of negative 8 is negative 2. Okay, so there's only one possible root when we're dealing with cube roots, and there's 2 possible roots for perfect squares with that plus or minus. All right. So we're going to jump down to the bottom left slide here. And we're going to estimate some of these roots, and then that's what you're going to do in your groups, and then we'll get you started on the homework in about 10 minutes here. All right, so here's our task for the day. And this is why you don't have calculators. Okay, with the calculators, you can plug these in, you can figure them out pretty easily. We're going to work on just estimating what the roots work out to be. They don't need to be perfect. Okay, we're not going to get them exact, because a lot of these are going to be some decimal that just actually goes on for forever. Okay, so we want to estimate root 95. This is where the perfect squares comes in handy. So I'm like, okay, I need to think about what number times itself is 95. I'm going to flip back over to that list of perfect squares, and I'm going to think about, where is 95? What two numbers does 95 fall in between? It's in between 81 and 100. Can we agree on that? 95 is between 81 and 100. So then I'm like, okay, when I square root 95, the value has to be between 9 and 10. The last thing that we need to decide, is it closer to 10 or is it closer to 9? Well, 95 is closer to 100 than it is to 81. So when I square root 95, that's going to be a little bit closer to 10 than it is to 9. So this ends up being, let's say, 9.6. Okay, and it's just an estimate. I don't know for sure. I don't need you to know for sure. But we do want to have an idea of what it's going to be close to be. Eventually, you can get the calculator and check your work there, but we're just estimating. Okay? All right, let's do one more together. Let's try like root 118. And this time I'll write out a little bit more of how we can check this. So root 118, again, I'm going to think about, where does 118 fall? 118 is in between 121 and 100. So I might write those down. 10 squared is 100. 11 squared is 121. And we're trying to figure out, where is 118? Well, 118 is closer to 121 than it is to 100. And so when we square root it, it's got to be in between 10 and 11. And it should be closer to the 11 because 18 is closer to 21. So we'll say 10.7. Again, I don't know if that's absolutely correct or not. It's just an estimate. We do not need these to be perfect. All right, let's do one cube root. Sorry, I said that was going to be the last one, but let's do one cube root, and then let you all fill in the rest of these, and we'll be done with this. All right, let's do cube root of 350. That's a big number there. So now that we're dealing with cube roots, I'm focused on my perfect cubes. So I'm going to flip back over and think, where is 350 in between? 350 is in between, oh, that's a typo there. See that 7 to the power of 7? That should be 7 cubed. 7 to the power of 7 is massive. Okay, but 7 cubed is 343. 8 cubed is 512. So I might write those down. 7 cubed, 8 cubed, 343, 512. And thus, the cube root of 350 is going to be in between those. It's pretty close to 7 cubed, right? 350 is only 7 away from 343. So I'm going to estimate this to be 7.1. In between 7 and 8. Any questions with how we're doing this? The what? Yeah, so that's why this cubing right here had me focusing on the perfect cubes as opposed to the perfect squares. So if I were to take the cube root of 350, it is going to be approximately 7.1. No, because remember, we're not saying, okay, if I want to say what number to the power of 3 is 350, then yes, okay, we're saying it's approximately 7.1. But when I take the cube root of 350, we're just saying what exactly is that number. We don't include the cubing. Okay, the cube root, we are undoing that cubing. Okay, so that's a good question, Ruben. When we state the answer here, we're not writing the exponent. We're just stating what number would be applied to that exponent. All right, here's what I want you to do. In your groups, estimate 18, 19, 21, 23, and 24. All I need you to do is agree on an answer with everybody in your group. Figure out approximately what that equals. We'll check as well, and I'll get you homework shortly after. Let's just see how we did here, and then we'll start the homework shortly after. So let's see, which ones do we have to do? 18, root 3, I said is approximately 1.6. As long as you're giving me a number between 1 and 2, I'm not going to count them wrong. Okay? 1.6, 1.7. Should probably be closer to 2, since 3 is closer to 4 than it is to 1. But not by much. 19, square rooting a negative. You cannot square root a negative. That's not possible, at least not without an imaginary number. We don't need to care about imaginary numbers yet, so we just say non-real number. All right, then 21, cube root of negative 6. That is in between negative 1 and negative 2. Negative 6 is a little bit closer to negative 8 than it is to negative 1, so approximately negative 1.7. 23, cube root of negative 30. Negative 30 is barely more than negative 27, so approximately negative 3.1. Then 24, 64 is a perfect cube, so it is just 4. That one we're not estimating. If it's a perfect cube, you give me the actual value. All right? Okay, that is it for today. I'm going to come around with the homework.